In number 2, we're asked what are the vertices, foci, and asymptotes of the hyperbola with the equation 4y squared minus x squared equals 16. This is not in standard form, so our first goal is to get it into standard form. And the technique for doing this is pretty much the same as with getting an elliptical equation into standard form. You divide by whatever that number is on the right-hand side, because we know that in standard form the equation always equals 1. And then we reduce each of the fractions as much as possible. So 4 goes into 16 4 times. This one cannot be reduced, and that's set equal to 1. Now, if you go back and you look at the formula, we can see that the a, we have an a squared and a b squared. They are always in the same order. So that means that when we look here, a squared is 4, so a is 2. And b squared is 16, so b is 4. Now remember, a is always what connects from your origin out to your vertices. And remember that when y squared comes first, since that's the vertical direction, we know we're dealing with a hyperbola that goes this way. So a is going to be this distance here, and that's 2. Now, b is the run for the asymptote. So this distance is b, which is 4. So you now know that your asymptotes are coming through on that angle. So the slope of the asymptotes is 2 over 4, or 1/2. So we have an asymptote with the equation y equals 1/2 x, because we know that we're going through the origin today. But we also have the one that would come in the exact opposite direction. So the two asymptotes or y equals plus or minus 1/2 x. All right, C will help us figure out where the foci are. And the formula for finding C is the straight Pythagorean theorem. So a squared plus b squared equals c squared. Well, we already have a squared and b squared in the formula, so we know that c squared is 20, and c is the square root of 20, or 2 root 5. So we know that the foci are above the origin and below the origin by a distance of 2 root 5. So I'm still at 0. I haven't gone left or right, but I'm either up 2 root 5 or down 2 root 5. So the foci are the point 0, comma, plus or minus 2 root 5. The vertices are above and below by 2 units. So our vertices are 0 and plus or minus 2, because again, they're above and below the origin. So we've identified each of the parts we're asked to identify, and now it's time to sketch the graph. We're going to keep the axes in the center of the graph. And we're going to take them and graph these points. So we have 0, 2 for the vertices and 0, negative 2. Our slope on the asymptotes goes up 1 and over 2, so it helps to sketch these in. We always draw the asymptotes with dashed lines because they're not part of the graph itself. They're not part of the hyperbola. They just serve as a guide for putting the hyperbola in. We always label the equations for the asymptotes because they're sort of the guides, and then we sketch in the hyperbola from there. So we're showing that it's a curve that never gets closer to the origin than the vertex, and it approaches the asymptotes. We show that it doesn't bend back away from the asymptotes. We'll typically label the vertices on the graph. If we can, we'll label the foci, but it's not necessarily required, especially when they're listed in the general information. Number 3 says if a vertex of a hyperbola is at the point 0, 10, and the equations of the asymptotes are plus or minus 0.5x, what is an equation of the hyperbola? Now, first of all, this is a little strange. I'm not sure why they would give it to us in decimal form rather in fraction form. It's easier to graph with fractions. Okay, so let's think about this for a minute. If I'm imagining a hyperbola with a vertex up here at 0, 10, then I know the other vertex is down here at 0, -10. So right away, we know it's going to be a y squared first hyperbola, right? As we start making the equation. This is the stuff we already know. We know it's going to be a y squared followed by an x squared. It's going to be a subtraction because it's a hyperbola, and it's going to be equal to 1. Now, if we know that the vertex is at 0, 10 and the origin is the center, then that means that a is 10 and a squared must be 100. So we can write a 100 underneath the y squared. Now, they told us about the asymptotes because we know the slope. So remember the slope of the asymptotes when it's vertical is a over b, because we just worked with that in the last problem. But that doesn't necessarily mean that a over b is 1/2. It means it reduces to 1/2. So we know a to be 10. So I can take out the a and I can put in a 10. And now I can cross multiply to find out what b is. So I've got 20 equals b. So if b is 20, then 20 squared is 400. And so that's our equation. We aren't asked to identify the foci, so that's all we need to do.